STEN presents a very innovative system, different from anything known. The STENdeckX system consists of primary beams up to 18 feet that are assembled into drop heads. These heads incorporate an anti-overturning system that works automatically. The system also has secondary beams that are placed on top of the primary beams, fitted into the grooves that they have on their top side. These beams incorporate high-grade steel fasteners that move along them and allow them to be firmly attached to the primary beams when required. The lateral movement of the beams is limited by the drop heads themselves. The system also allows bays with a width less than the standard one. The elastic fasteners remain retracted in the parking position until required. Then they firmly attach both beams and prevent displacement or overturning. Additionally, longer secondary beams can be used to easily build cantilevers up to 4 feet that are secured by the double high-grade steel fastener incorporated in the 10 and 12-foot secondary beams. These elements can support up to 5 times the working loads that occur on the cantilever. The bracing pipes are set up from the ground thanks to the 4 anchoring points incorporated in all the drop heads. This reduces to a minimum the number of diagonals needed to fully stabilize the system. The telescopic bracing pipes allow their length to be adjusted to adapt it to different bay heights and widths. This way, the bottom end can always be set close to the base of the post. By being able to set up the secondary beams out of the grooves of the primary beams, it is possible to continuously adjust the dimensions of the formwork in the direction of the secondary beams. The system allows the primary beams to be overlapped so that the length can also be adjusted in the other direction of the formwork. To proceed with the assembly of the overlapping beams, the overlapping distance must first be adjusted. To do this, the last 2 beams of each alignment are distributed on the ground, one at the base of the system and the other at the desired distance from the end of the element to be formed. Once the overlap is adjusted, the 2 beams are connected using the overlap head, which is installed in the position indicated by the end of the adjustment beam. And it is firmly connected to the preceding beam. The beam is lifted with the head already installed. And the adjustment beam is placed in the ladder. Both beams are firmly joined. Thus, the necessary length is achieved in each alignment of primaries, and the easy solution of irregular perimeters is ensured. The continuous adjustment in the direction of the secondary beams allows the creation of bays with the desired width. Even if it consists of non-parallel main beams, the elastic fastener provides secure connections of non-perpendicular beams. The drop head has pivoting supports to facilitate the insertion of the primary beams. It also incorporates a fast recovery system using a cross wedge and has anchors for bracing on all sides. At the top, it has retractable springs that allow the primary beams to be installed by tilting from the ground or vertically when they are set from a high platform, like a scissor lift. Thanks to these springs, the beam is secured against loads on the cantilever. The cantilever loads in both directions are automatically stabilized, thanks to the set of connecting elements of the system. In the case of loads on the ends of the main beams, the anti-overturning device, incorporated in all standard drop heads, ensures the stability of the system. The cantilever loads on the secondary beams are transmitted to the primary beams by using a double elastic fastener incorporated in all the 10 and 12-foot beams. At the corners, the cantilever head prevents the loads on the secondary beams from causing an unwanted movement of the primary beam. This head connects the beam to the post, and the diagonal stabilizes the whole set. This head maintains the same wedge recovery system and the anchors for bracing. It comes at the top with a tilting part that allows the beams to be installed easily. and secures them against vertical loads that can occur in areas close to corners. The combined work of elastic clips, drop heads, and bracing ensures the stability of the system in all situations. The design and reduced weight of the secondary beams allow a single person to assemble them quickly and safely from the ground. The use of the portable gauge allows them to be placed in their final position with precision and speed. The 8-foot gauge is easily moved as the assembly progresses. The secondary beams placed on the cantilever are lifted from the inside of the slab perimeter and slid into their final position with maximum safety. Thanks to this combination of cantilever solutions, it is not necessary to change the direction of the main beams. Even 12-foot beams can be assembled from the ground and with the worker within the perimeter of the slab. With this assembly method, corners are resolved easily and safely. All that remains is to lock the fasteners of all the cantilever beams to secure the corner. The cantilever head ensures the stability of the primary beams in the cantilevers, which, combined with the 12-foot secondary beams, allow the corners to be solved in a simple, fast, and safe way. By being able to overlap the main beams, the cantilever can be adjusted continuously and independently in each alignment. In addition, secondary beams can be installed at a wide range of angles. Once the elastic fasteners are locked, the position and stability of the secondary beams are ensured. Thanks to the use of metal diagonals, the number of bracings is extremely reduced. Once the first bays of each alignment have been braced, the assembly progresses quickly without requiring any type of bracing, since the effect of the diagonal extends through the system itself. It is enough to brace one diagonal every 5 bays, resulting in an impact that can drop to 1 bracing per 200 square feet. The range of main beams is made up of 18-foot beams, which require 2 intermediate post shores in a standard configuration, and the 12-foot beams, which only need 1 intermediate post. The 8, 6, 5, and 4-foot beams are supported at their ends. For the construction of sloped slabs up to 20%, the system has a recovery head that adjusts the relative height between primary beams. It has aluminum and stainless steel elements to achieve a contained weight and great durability. Its design allows the post and drop head to remain completely vertical. The ramp head incorporates graduated shifts where the slope percentage of the slab to be built is directly adjusted. Thanks to this, the beams are perfectly aligned. The system allows the use of the same elements used in the flat slabs to safely and efficiently resolve the formwork of the bottom of the drop beams. It is only necessary to secure all the secondary beams with the elastic clip to achieve maximum stability. The system offers a very high assembly speed on flat slabs, thanks to primary beam lengths up to 18 feet. One carpenter assembles the basic skeleton, made up of the primary beams and the posts that support them at their ends, the secondary beams closing the grids and the bracing. Three carpenters follow him, installing the rest of the secondary beams. Once the assembly of the basic skeleton is finished, the first carpenter installs the intermediate posts. Cantilevers and corners are resolved with great ease. Finally, for correct installation, the elastic fasteners of all the perimeter beams must be checked. In the example shown, 2,000 square feet were assembled in 28 minutes.